Hi everyone. In this video we are going to see what are the op-amp characteristics and how the values of ideal and practical op-amp characteristics will differ, and also in this video you are going to see the internal circuit of practical op-amp. So if you consider coming to the internal circuit of ideal op-amp, so this is the circuit that we are considered. So from this circuit we can say that the following things or the following points that can be observed from this ideal op-amp circuit is: first point is, if you consider the currents, that is I1 and I2. So this ideal op-amp draws no current at both the input terminals of operational amplifier, since the input impedance of the operational amplifier is high. Okay, so from this we are going to see the two ideal characteristic parameters. One is the input currents and second one is the input impedance of op-amp. And the second parameter we are considering is, here we are consider that the AOL is infinite, which means that the gain of an ideal op-amp is infinite. Hence, for the differential input is 0 for finite output voltage. Okay, so which means here the VD value is 0, but there exists a V0 value. We know that why AOL is infinite. I have already discussed why AOL is infinite in the previous videos. And the third point we have to consider is the output impedance is 0, hence the output can drive an infinite number of other circuits. So these are the three major points that we have considered when we are considering that the op-amp is operating in ideal mode. Okay, now just a glance, see what is the ideal and practical op-amp characteristics. So these are the 10 parameters that we have to consider while operational amplifier, and here the practical value of operational amplifier is considered only for the IC741. Okay, here the ideal values of operational amplifier will be same, but the practical values of an operational amplifier will differ for different manufactured ICs, or we can say for different IC numbers. Okay, so this peak is seen only for the IC741. These are the practical values for these parameters of an operational amplifier. Now next we are going to see what is the definition of each parameter and how it will be calculated. So if you considered the first parameter, that is the input offset voltage. So this input offset voltage is nothing but it is a differential voltage that must be applied at the both the input terminals of an op-amp in order to make the output voltage 0. So it is denoted as V suffix IOS. Here this IOS is I indicates input, O indicates offset voltage. Okay. And now we are going to see what is the second parameter, that is the input offset current. So this input offset current definition is, it defined as the algebraic difference between the currents flowing into the two input terminals of an op-amp, and it can be mathematically expressed as IB1 difference IB2. Here we have to observe that the current is always positive. And the third parameter is the input bias current. So this input bias current is nothing but the average value of the bias currents that are flowing into the op-amp input terminals. So this input bias current can be expressed mathematically as IB1 plus IB2 by 2. And here next parameter is the input resistance. So this input resistance is defined as the equivalent resistance that is measured at either the inverting or the non-inverting input terminal by making the other terminal as grounded. So it is denoted with the letter R suffix I, which is nothing but input resistance. And now the next parameter we are going to see is CMRR. This is already we have discussed in the previous videos, that is the common mode rejection ratio. So it is defined as the ratio of differential voltage gain to the common mode voltage gain, and it is mathematically expressed as CMRR is AD by AC. Remember, this CMRR is always a positive. And the next parameter is power supply rejection ratio. In short, we can write it as PSRR. Okay, so this PSRR is defined as the ratio of change in input offset voltage. So we have seen what is the definition of input offset voltage. It is indicated with V suffix IOS. Okay, it is the ratio of VIOS due to the change in supply voltage, producing it, keeping the other power supply voltage constant. Now, with confusion, we are having that supply voltage. One supply voltage is producing and we are maintaining other supply voltage constant. What it means? It means that we know that the operational amplifier is having two power supplies. One is the positive supply voltage and second one is the negative supply voltage. So what we have to do is we have to change the positive supply voltage with maintaining the constant negative supply voltage that is observed. Okay, so we can say that the PSRR is also called with other name, it is power supply sensitivity. So the PSRR and PSV is both are same. Now we can express it mathematically. The PSRR is, so ratio of change means we can represent the change in terms of delta. So delta VIOS by delta VCC by maintaining the other supply constant. So what is other supply? It is VEE. Okay, so by maintaining one supply constant and by changing the other supply. So these are the two mathematical model representation of or mathematical model equations of power supply rejection ratio. Now next see what is the other parameter, that is a slew rate. So this slew rate is defined as the maximum rate of change of output voltage with respect to time. So this slew rate is always specified with in terms of voltage per microsecond and it is mathematically expressed as dV naught by dt max and it is indicated with the symbol S. And the next parameter is output offset voltage, which is nothing but VOS, and it is defined as the output offset voltage is the DC voltage present at the output terminals when both input terminals are grounded. So these are the parameters that should be considered while we are designing for any application of operational amplifier. Now we are going to see what are the values of ideal and practical op-amp for the parameters. So here if you observe in this table we are having 10 parameters. Okay, so now first parameter is the open loop voltage gain. Here the voltage gain is defined as the ratio of output voltage to the input voltage when the op-amp is operating in open loop mode. Okay, it is represented by the symbol AOL and its ideal value is infinite, and for the typical IC741 the ideal value is practical value is 2 into 10 power 5. And the second parameter is output impedance. So it is represented by the symbol Z suffix out, or we can represent it as R suffix O, and here the ideal value is 0 and the practical value is 75 ohms for the IC741 op amp. And the third parameter is input impedance. It is represented with the symbol Z in and its ideal value is infinite and the practical value is 2 mega ohm. And the fourth one is the input offset current. We have seen the definition. It is difference of two bias currents and it is indicated with the symbol I suffix IOS and its ideal value is 0 and practical value is 20 nanoamperes. And the fifth parameter is input offset voltage. It is indicated with the symbol V suffix IOS and its ideal value is 0 and practical value is 1 millivolt. And the bandwidth is, it is indicated with the symbol B dot W and its ideal value is infinite and the practical value is 1 megahertz. And the CMRR value, it is indicated with the symbol rho and its ideal value is infinite and the practical value is 90 dB. And the next one is the slew rate. It is indicated with the symbol S and its ideal value is infinite, whereas the practical value is 0.5 volts per microsecond. And the next parameter is input bias current and it's indicated with the symbol I suffix B and its ideal value is 0 and practical value is 80 nanoamperes. And the last parameter is power supply rejection ratio. It is indicated with the symbol PSRR and its ideal value is 0 and the practical value is 30 microvolts per volts, and here this PSRR is not having any unit. Okay, here V by V, these two will get cancelled. Next we are going to see what is the equivalent circuit of a practical op amp. So here we are considering the Thevenin's internal equivalent circuit of this practical op amp, which is shown below. Here this operational amplifier amplifies the difference between the two input voltages. Okay, so this is in open loop mode. So we can write the V0 expression as gain into input voltage. So here it is open loop. So we can write the gain as AOL or A. So V0 is A into VD. Okay, here this output voltage will always depends on the difference voltage, and the R in and R not is nothing but the input resistance and the output resistance of an operational amplifier. Here this op amp is called as the voltage controlled voltage source. Why? Because here this differential voltage will controls the output voltage. Okay, so we know that the VD expression is difference of higher voltage minus lower voltage, so it is V2 minus V1. So this is the Thevenin's equivalent circuit of a practical op amp. Thank you.